Hello. Do you know what is a cuboid? Well, the name kind of is similar to a cube. Well, a cuboid is pretty much related to a cube. The difference is a cube has, the length, breadth and height of the same length, but a cuboid has different lengths. That means the size of the length, breadth and height may be different, not the same, which is in case of a cube. So we live in a world which is full of cuboids. These boxes you're seeing are basically cuboids. Your room may be a cuboid. Your college building may be a cuboid. So pretty much everything may be related to cuboids. So let's see what formulas we've got for cuboids. So a cuboid is also known as a rectangular paralleloparallel, or in other words, you can also call it as a rectangular prism. So a cuboid has a length, it has a breadth, and it has got a height, right? Similar to a cube. So we are going to look at three formulas related to cuboid, which help us to calculate volume, surface area, and the length of the diagonal. So what will be the volume of this cuboid with length, breadth, and height? Well, volume of any consistent or a proper figure would be the area of its base times its height, isn't it? So what will be the volume of this cuboid? Well, the area of its base will be L times B, because the base is basically a rectangle. So L times B times the height. So the volume would be LBH. So that's the formula for calculating the volume of a cuboid. What will be the surface area? Well, a cuboid has got 6 surfaces. So the surface area will be the addition of all of these areas of each surface, right? So what will be the area of this surface? Well, it would be B times H, because it's a rectangle. So this is B times H. What will be the area of this surface? I'm sorry, my drawing is a little bit bad. Please bear with me. So the area of this surface will be H times L, right? And the area of this top surface will be B times L, because this is B and this is L, right? So there are two areas like this, two areas like this, and two areas like this, isn't it? Two surfaces basically, I would say. So we have 2 times BH plus 2 times, let's say, LB plus 2 times HL. If you're still wondering why there are two surfaces, pick up any box. You'll find that this surface, which is B times L, will be similar to its opposite surface. This will be similar to its opposite, and this will be similar to its opposite. So it's kind of hard to explain in 2 dimensions. Pick up a box and see how it is, right? So we have the surface area like this. If I take 2 common, it will be 2 times LB plus BH plus HL. So that's the surface area, and that's the formula. Let's move on to the diagonal. How do you calculate the length of a diagonal? Well, let me first draw the diagonal. So a diagonal is a line which connects one vertex to its opposite vertex. So this red line is the diagonal of this cuboid. Now we can calculate this using Pythagoras theorem. To calculate the length of this red line, we'll have to calculate the length of another line, that is this green line. So if you look at it from here, that means from downside, you'll see that this is basically a rectangle, and that makes this a right angle. So by Pythagoras theorem, the length of this green line would be under root of b square plus L square. Now this length is h. So I have h here. Now again apply Pythagoras theorem, and you'll get it as base square plus height square. That's under root b square plus L square whole square. That will make it b square plus L square, and plus this square, height square. So L is basically under root of b square plus h square plus L square, right? So we have the formula for calculating the diagonal's length, and that's under root of L square plus b square plus h square. So these are the formulas, keep those in mind because we will be solving a lot of questions. Let's solve one right now. So the question is, a cuboid has a length of 9 meters, breadth of 8 meters and a height of 12 meters. You have to find the following: the length of its diagonal, its surface area and its volume. Well, you already know the formulas, so this question is very easy for you, right? So let's first calculate the diagonal. So it is under root of L square plus B square plus H square. So this will be under root of length is 9, so 9 square plus breadth is 8 square plus height is 12, so 12 square, and that will be under root of 9 nines are 81 plus 64 plus 144, right? So this will be under root of 289, and under root of 289, you should know it, is equals to 17. So the length of the diagonal is 17 meters. Let's calculate the surface area now. So this will be twice of LB plus BH plus HL. So we have twice of LB. Let us write it actually. 9 times 8 plus we have BH. So 8 times 12 plus HL. So we have 12 times 9, right? So this will be equals to twice of 72 plus 12 8s are 96 plus 12 times 9 is 108, right? So this will be equal to 2 times, let's add these up, you get 276, and if that is multiplied by 2 you will get 552, and this will be in meters square because that's the area, right? Let's calculate the volume now. Well, it's simple, LBH. So we have 9 times 8 times 12, right? And that will give you 864. Okay, so this is how you solve questions. Pretty easy, huh?